To observe all the activities, of course, we are conducting this week and the next week in our university. But today we would like Carlo to talk about something he's not sure why he's here talking about this. But we have been discussing this all the time. But we want to talk about a life cycle assessment, but not only life cycle assessment as a process, as a lonely process. We would like to see you to sign because we have now engineering students and we have design students. So maybe we can see what is the relationship. I think we speak about in life cycle assessment class. Why do you want to do life cycle assessment? Okay. So Carlos has a lot of experience because he was there when this issue of life cycle assessment was just like getting important, and he was there to make all the research about what life cycle assessment is useful for design. He has written a lot of books about that and how that is evolving into new ways for design. But I'll let Carlos
Thank you very much. Now it's an honor to be, and a pleasure to be here. But I have to be honest, Sandra said to me, oh, you have to speak about this and this and that. It's like describe the universe. So I don't know what I'm going to say to you. I don't know if let's make it how it goes, okay? So I don't know, I have even this in hands. It's a pleasure. Sometimes I have even some presentation in nothing in Spanish, unfortunately. There'll be some part in English, some other in Italian. Maybe we can take something from here, from there, but I don't know exactly. So it's let's go even in the direction that you are interested in, because it's really a big issue. Or before saying this, I would like to ask you, do you know what life cycle assessment is? Oh, it's a long time I'm not using this. Whoa! It's really nice. That's a question mark. Not all? You didn't use it? You have been using? So who wanna tell me what is the life cycle assessment?
Even if you want los que participar en español.
It's not. I'm not giving you a mark.
Los que quieran participar en español podemos traducirlo para los chicos de ingeniería.
Okay. Now it's just to start a discussion and so to the disposal of things. And what to analyze?
Production. Okay.
Okay, you analyze the life cycle phases, the pre-production, production, distribution, use and disposal. Okay. Good. Let me start. Good one. Said this, what no, I'm sorry. Said this, what is the results that you have after the life cycle assessment?
Well,
some economical output?
It was a number.
Please.
We see the environmental impacts in the production of a...
And you have the results in terms of environmental impact. Okay, this is the point. Okay, so we analyze the product, whatever is this one, and or I don't know, my computer. But it's enough to assess the life cycle phases, or there is another key important thing that you have to take into consideration. You analyze the life cycle phases, but there is another key important thing that you have to take into consideration, which is if I want to compare a car with a bus in the life cycle phases, this
Phase of reuse.
in the life cycle phases, basically the bus is being lots of material, is consuming more than the car. So the bus that transports lots of people is with a higher environmental impact than the car. It depends on what? On
The phase of reuse.
no, the phase of the use we compare, but there is something that is missing, which is the functional unit, yes. Okay, now this was just to, because I understood that it's not said that all of the students were aware about life cycle assessment. We don't have to say, we don't describe now what is life cycle assessment, how it works, because not all the person have been using this, but you evaluate the global warming, acidification, eutrophization, all this, the environmental impact. Okay, we get the point. So we have a tool or a method or different tool to evaluate the impact of a part. This is already good. So now this is not anymore this. It's this. You know what it is, okay? But I have a second question then. Why? Why we use a life cycle assessment?
Because I think that it is important to take into consideration the impact that we are living in the world, and also, you know, not only concentrate ourselves in selling something, but also like what we are living in the world.
Okay, yes, it's important to do that. But when you have this result, what you do about this? I evaluated for this the global warming potential is something, you know, X. Maybe the acidification is something else, the ozone layer depletion is something else, and so on. And what we do with this? If I say that the global warming potential of this is 332,
We can analyze the world.
and we can choose a citizen. Okay. It would be nice that when I go to buy a mobile phone, a chair, I know that bless you. We can choose. I can choose between one and the other. You said money, maybe that costs more, but I know that I have to do something, or maybe it's not. Maybe that many times it's not, because many times if actually you are using less resources that has a higher impact and so on, it could be that product with a lower environmental impact may have even a lower price. This is not said. Okay? The situation is more complex, but this is just to say. Okay, I can choose. I can choose what is here around. I go, I don't know, to buy some food. They take me here a coffee with discount and so on. But this is what is here. And you think that the product that surround us are environmentally sustainable, even though I choose the best of those products. You know, I made another question. You know how much the student that were together with us in the other classes, they were introduced to the dimension of change. If we want to have a sustainable system of production and consumption worldwide, you know how much we have to reduce the consumption of resources, or let's say the environmental impact, the consumption of resources in 2050, changing, so that are really so all 90% less impacting? The answer is definitely no. Okay, I can give that to you. So it's just LCA we are using just to compare and to choose, or we can do something else.
Change habits.
Change habits, yes, this is good. But
And how we produce. For example, it's a tendence that we are producing some part of the food in common areas, like in apartments. Some people are getting organized to produce certain vegetables, for example. So, like that kind of change of habits.
so what we have to change, go a bit deeper. Think even about, yes, food, but think about what we have here so that it's easier our understanding. What we have here around, I tell you, a sustainable world will not have the product that we have here around, okay? They will be totally different. Some of you are engineer and some of you are designer. What are you doing? Sorry? Collaborating? Yes, that's good. And I love this. I have a mixed education. I've been studying engineering, design, and art, so I'm a mess. But said this, the collaboration in myself is a help. But it is another story. No, the point. No, the interdisciplinary is another issue. But said this, both either engineer and designer, what they are doing?
Creating things.
Creating things. We use another word, which is designing. Okay, we design. Okay, either on an engineer level, either on a let's say industrial design level. So it's okay. We are designing, we are changing. So we have the possibility to change the chair, the mobile phone, my laptop, this board, this webcam, not him, he's good. Okay, so sorry? No, what I said, sorry?
Where it can be used.
Yes. So where we can use it?
Everywhere.
Everywhere. That is a fair question. In fact, which is, okay, I made another question. Which is the first phase of a life cycle assessment for those that have been studying? Sandro, the professor, I'm not allowed to speak. No, of the methodology. The first phase of the methodology. Definition of
materials and
no, come on, of the methodology. Translate, maybe I misunderstood. You define the scope and the objective. You remember, you make inventory, you make the classification, characterization, normalization, and relation. You're aware about that? No? More or less? Okay. Defining the scope and the objective, it means why I'm making a life cycle assessment, and then you can do it in different ways. what we said before. We need to change. How we change? We design. So, it's good to use FCA in design. It's there where it's the most important, okay? You can say, I can assess what is bad and good around. This is made, of course, this is with a higher environmental impact than this, because this is mine and it is his. but that is what has been produced by someone that didn't have any knowledge about designing for sustainability, okay, and any knowledge about how, if really this is with a lower environmental impact than that, okay. So if I use life cycle assessment into the design process to have the knowledge on how to make a product to be with a lower environmental impact, that is the best use we can do, isn't it? So it's not to say, okay, this is good and this is bad, and we are in the same world, nothing changed, okay, I start to change. But since we have to change so much, we have to integrate a powerful tool which tells us, even though with some limitation, if in the design process we are going into the correct direction or not. So the key point is how to use life cycle assessment in a design process. Okay? Do you agree with me? Or you say yes? You want to repeat this? No, of course. No, you get the point. And why I'm saying this? Because life cycle assessment as a methodology and as a tool did not started, within the scientific design community. It was made by analysts in the Leiden University, the first. Lots of things. Design process is basically made. Can we make a scheme of a design process? Who's good in design methodology that want to help me to draw a very generic phases of a design methodology? Carlo Benzoli, come here. Okay. So, at the beginning, okay, there is a design brief that is given by a company usually. Together with the strategist, okay? Alejandro will say something there. Okay, I'm making a schematization. The design, when you design, the things goes in the way they go, okay? Any schematization is take the risk of making the things very simple, and many times, a design action come out in a very different way. You get an inspiration and something come out. But to express something, anyhow, there is a process, and I make this kind of schematization. After the design brief, usually what you came out with. So this is given by a company producing the chair, and said, I want to have a chair that is with a low environmental impact, that this has to be used by the students, in the class, and blah, 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 blah. So the next, usually we speak about concept design, okay? The next phase, you develop some concept. And after the concept, you go on and you have a detailed design. And I'm not typing that good. It is so that I not use that anymore. Then you go to the engineering phase, okay? Okay, so let's say this is all the time an iterative process. So you go down and you go up, you go down, you go up, and it can vary, okay? Where do we use a life cycle assessment? How can we use it?
During the concept,
During the concept.
in the pre-stage,
Sorry?
concept, engineering, and
We use, you said we use SCA here, SCA here, and SCA here. I make you another question. Where do you think that SCA is easier to be used? When the project is engineered, we know everything about it. When it's detailed, we basically know all the detail, but not all the processes to produce it and other things. In the concept, when we have a draft idea of what it is more easy to be used for life cycle assessment.
in the engineering part.
Sorry?
In the engineering part,
Great. Why?
because you have what you need to measure, you have the measurements, you have the you have the materials, you have the processes, so you can come back to the design part and read down the engineering process according to the LCA results.
We will come to this later. But you said something correct. The usability of an SCA, it's higher here and it's lower here. And make another question. When it would be more useful to have information from a life cycle assessment? To have information, to know.
The brief.
Sorry?
The brief.
The brief. Yes, and why?
Because in that stage you will know how all will work, and so you have an idea of what you need and what is good for all the people who will consume all of what you are going to produce and you are going to do.
Try to give other contribution to what she said.
Well, I agree with her because I think that it is important to know what kind of things you need to focus to develop a concept. For example, if it's the energy, the water that I am using, maybe the material.
Yes. The point is, please.
I think another very important thing is in the brief about bureaucracy is that you understand in that step from who you are going to design, because it's not the same design to every company. I don't know if I'm correct, but in that part you have to be very clear for what you're going to design after concept, detail, and engineer part.
Yes. So if I can say that was correct. The point is that when I'm here, I have a chance at the beginning of the process to change a lot. The concept could be diverse. I could, make something that is totally different. All right? When I'm in the engineering phase, I can maybe change a little bit. The finishing system could be a bit different from the other. But what the level of innovation that I can put to the product that I'm developing is much lower because I have already quite defined that. Okay? So the importance goes in the other direction. So it's key important to have good information at the beginning when I can change a lot. Okay? So I know where I have to change, where I can gain the most for that chair that I didn't know. Is it in the disposal phase? Is it there? Is it okay? Then at the end. Of course, let's do it here. Anything we can improve is, so this is going this way. It's bad, it's the reality. But there is something that we can do. Can we make a life cycle assessment here? In the design, in the brief, in the design, even before the concept.
What was the question? Sorry.
Can I make a life cycle assessment after the company?
I can general view of what you are going to do after the product is.
A general view is not a life cycle assessment. A general view, a life cycle assessment means that you have to have all the information of all the processes of the pre-production, production, distribution, use and disposal in relation to a given functional unit. On what? We can do this. Sorry? Materials is the pre-production.
A similar product, another similar product.
On something that I don't know what it is, but there is a real product on which I can do a life cycle assessment. So I can have the type of product that I'm going to redesign. If that is the chair, I will take this chair and so on. Okay? So we take a reference product onto which we make a life cycle assessment to understand which is the environmental profile in terms of environmental impact along the life cycle phases. Okay? I made you another questions. Would you do it on if you are going by a company, we are doing this, consultancy company and doing life cycle assessment and redesigning product and so on. Would you do it that on the product that is the best seller that they are selling right now, or on which? I already said something, I should have said a little bit less. What do you think is the best to make a life cycle assessment, to have information to redesign something?
The one that I think that now is the one that has the less impact. So I could reduce it even more.
Oh, that's a good. That could be one. Yes. The less impacting, but you don't know which is the less impacting before you have made maybe 1,000 life cycle assessments, so it could be a bit costly. Make a life cycle assessment. If we make a life cycle assessment, we ask from 30,000 euro to 80. So it's a cost well we have to do it really toughly. Actually, I'm going to say this on the most advanced product. Okay, it's not the one that is the most solved. Maybe it's with the low technology, it's not really, there where will be the next generation of chair or computer. It's useless if you have to redesign to get information of the most computer when you have information on something that will not be on the market anymore. Okay? So you take the most advanced, even though it's not the most fair. Okay? So the most typical, but that represent at the best the evolution. So maybe they are selling just one, but let's take that one. Okay? So this is one action that you can do. Okay. So now I have to think where I can go on because I have to invent everything. Okay, so you use life cycle assessment. Then are you? No. Okay, so we can say this. So I make a life cycle assessment here on an existing product, and we say what type of an existing product. And what we can do here in the concept phase, on the detailed phase, and on the engineering. Maybe here on the concept phase we have a couple of concepts, concept 1 and concept 2. What we can do. Maybe it's good to make it's called an abridged life cycle assessment, a simplified life cycle assessment. Okay? That means that you don't know all the details about that, but anyhow it's worthwhile to make it. The reality is that life cycle assessment, many times it is a cost. Many times you don't have your own, I hope that any designer should be able to use a life cycle assessment, even though in the way that we should use it, not as an analyst. Maybe that is not a big issue. If you have maybe to compare two types of material that are similar or two types of processes that are basically similar, then you focus and then you can make a selection about that. And the same happens when you are here in the engineering phase, okay? Then, okay, you did, in this case, you have been using a life cycle assessment as a tool that has addressed you to understand whether you have to concentrate on the disposal phase, because that was the worst, or in the pre-production, in the selection of material, or in the use phase, because you are consuming lots of energies and something like this, okay? At the end, of course, in the company are always asking, well, if they come by me, they ask, I want you to make a life cycle assessment to say that my product is better than the other. And say, but if your product is worse, what I'm going to say, it's worse. First you have to design it better, then we can say this. But of course, then we have the communication part of that. So it's good, I don't know whether he's the designer or not. We as the research center, we are making even life cycle assessment that confirm this existing with the one that we have developed, hoping that your concept is here and the other one is here. Okay, the existing is there. Where we go on? No, and what we can say. Do you know anything about life cycle design? Not as much? It's a bit long. It's a long lecture. But since we are designers, we have to think that life cycle assessment is not is one supporting tool of life cycle design. So life cycle design is here. And among the supporting tools, you have even life cycle assessment, plus other tools. Okay? Others would say differently. If the scope is to make the eco label, label for the environmental impact of some product or something like this, or to say whether one is better than the other, okay, the scope is just to make the LCAs is the main tool, but when you have to design, there are other tools. Are you aware about other tools that can be used in a design process? Do you have any clue about that? Yes? Who said yes? Please.
Other tools I remember the period before. We used some tools. Eco-material supervisor, that it's like a plugin in 3D software.
And this is what is doing this?
The last one that I mentioned.
Yes.
It's like analysis that you can establish in a 3D program.
3D Max or Lost?
Yes.
It's in Inventor. What else?
So that
I don't remember the name in English. La Rueda Ecológica. It's with.
yeah.
It's with. That's what
Yes.
I remember.
In fact, there are some tools, 3D modeling tools that, since they actually can evaluate the volume and through these specific weight and of the material, blah blah, you know the weight, and then you can calculate, and so you have even a performance, and you can compare this. But that is, and you have this into another tool, so they are incorporating environmental impact into 3D modeling tools and so on. But this is not that different from, having, it's more comfortable because you have it there and you have it, you have the evaluation. But it's not that different from taking the value there, putting this information into SimaPro and having the results. Okay, it's not that. The point is that when you are now the scheme is coming very complex here. Yes, I want to say what I want to say. This. So I have saved the phases. Of a design process, the use of LCA, which makes like this, okay, and the efficacy of using it, okay. This is the design process. On this side, we have usually we call assessment. Tools or method, because they assess something and we use, okay. But there are even other type of tools that are more, we call, or orientating tools. Because life cycle assessment tell you, this is the problem, there are the problem, okay? But set this, okay, I know that there is a problem. And then, what I can do? So you have to have a knowledge, read this book, Sorry, it's not that. Go in the library. No, I wrote a book on product life cycle design. And there is a knowledge on how to design a product with a low environmental impact. So it's not enough to know where are the problems, but even how to design for reducing the environmental impact. Okay, and so we have given this knowledge, some tools that embed this knowledge to help you, to support you in the design. When we speak about life cycle design, usually this is helpful for designer. We identify some design strategies, no? Because this help us to orientate, in our mindset, to orientate design process. You know anything about life cycle design strategies and guidelines? Are you aware about that? How to design product? Because one thing is to say, this is the profile of the environmental impact in the phases. Yes, but said this, I tell you which are the design strategies because you don't know. The common, usually it's shared in the community, that could be a little bit different, but actually you can design for product, life, extension or optimization to design long-lasting products. And you know why this is interesting? Remember how much time I have?
20 minutes.
20 minutes. So I think maybe I have to go fast. I have to give answer to myself. If we design something that lasts longer, if you think in a life cycle phases, what we avoid? The disposal, yes, please, and if this is disposed where he's sitting on nothing, no, we need another chair. So we have to pre-produce, produce, and distribute another one. So we avoid those two. So design for long-lasting product is very important. So for example, if in a life cycle profile we have the pre-production phase is very impacting. That could be because we have very impacting material, but even because the product lasts nothing. Okay. So this is life cycle assessment is the analytic side that gives very important information. But then we have to use, the way in which designers think. So one big strategy is to design for life cycle extension. The other one is to design for material life extension. That means design for recycling, design for energy recovery, and design for composting. That is design for material minimization, energy minimization, to reduce toxicity, and for design for material and energy renewability. I'm not writing all of that, okay? Basically, these are usually the 6 design strategies that are used, okay? And in relation to these strategies, different guidelines has been defined. So now I go back to this and I show you one tool that will help you.
¿No está conectada la compu?
This is a toolkit. It's an Excel-based toolkit, so it's very simple. And yes, you can pop in the product that you are analyzing. Does the product system tend to wear out easily? So you have to check about these and in which parts of going through this checklist you understand, even though in a qualitative term, whether there are problems or not related to sustainability and in relation to the design criteria. And when actually this is made, you can make for all of the criteria. You see, this is energy consumption, material life extension, toxicity reduction, and conservation. So you can write here inside. You can decide, and you will understand whether this has a low priority in relation to maybe material consumption, that is the effect of, yes, with a high priority of the chair or something like this. Either you come with a CA result, can give you more solid information, or with a qualitative one. So you can have this kind of information that are quite useful. Then what you can do, and this is an orientating tool, now you don't read that well over there, but this is, here again we have 6 idea generation table that you can use when you brainstorm. Okay? You are not alone, with a group, your design studio or in a company, in a design department. You can brainstorm, and we are doing this, and you design and you brainstorm, for example, on material life extension, and here inside you will find guidelines. On the same book there are the same guidelines that are here are in English, but here are in English, in the book are in Spanish, that suggest you how to design for long-lasting product. For example, facilitate maintenance and how you do it, and there are sub-guidelines. So, of course, these are general guidelines, but you think about this in relation to your product. So you come up with some idea. So what you do, you take one of these ideas, you type inside, and you brainstorm, and you move from one criteria, one idea table to the other. This is energy consumption reduction. You have other guidance related to that may suggest you something, and so on. And you go on, and you can give usually, for example, with Artemide, you know Artemide making line, we had them to redesign Tolomeo, which is the best seller that they are making, because it's quite impacting because of the line that they are using. So they asked us to do this. So we were there with all the research groups, 16 person brainstorming on that, you know, having identified priority before, using LCA on the existing product and so on. But this is an orientated tools, okay? So this gives to you guidelines and information to design a promising product. So what you can do then, when some of those, if you devoted some time for doing this, you can, you are here, you can collect these, oops, okay, you can collect the idea, you can take and copy and paste the idea on the radar diagram, the most promising, and then you start reasoning on which of those could represent the starting point of your concept and something like this. Okay? And this is not a life cycle assessment, so it's important to understand the problem. Good if you have it. You don't have it, use anyhow qualitative tools to analyze the system, but the work is not there ended. Then you have to design, okay? And you have to have a knowledge on how to design with a low environmental impact. So you have to have this knowledge, as you have to have a knowledge about the material, how the performance of the materials and the other things. You have to have it even on how to design product with a low environmental impact, okay? And this is a knowledge that is embedded in a support tool. Then, as I told you, you can make a comparison again with a life cycle assessment. If you didn't do that with a life cycle assessment, this tool lets you make a qualitative analysis in terms of how much you have following the design guidelines that were suggested. And for example, you have different level of making the analysis. Now I have selected the normal one. You see here there are the 6 strategies. For example, energy consumption, and you can say whether, in terms of optimizing energy consumption in the transportation, you said, well, here I made a radical improvement. So it's a qualitative assessment that you can do in relation to this. And all this is it's a software, it's an Excel file, and this will be reported at the well, let me put something here, some others, so you will see. Radical. Here, you go to the radar diagram, and this was, I selected the normal, and so you see the performance of your product. This is, nothing has changed. Here you have an incremental improvement, and here you have a radical improvement. So for my evaluation, I didn't change on any of the other, but I was evaluating in terms of how much I did to extend the life of the product or to reduce material or these other things. And you have an incremental improvement in relation to toxicity reduction, for example, okay? You can do this up to this level, or you can do it even very deeply. Very deeply means here you cannot read, but you have all the guidelines, and you can say, yes, I have accomplished the guidelines partly, no, and you count this. These are lots of pages. It takes some time, maybe half an hour to do it, or something more. But then you have a performance which is actually more detailed, okay? So you are deeply going into that. But doing this, it's even helpful for you to understand, oh, actually, I didn't actually try to use a two-way snap fit to make the two part easily to be disassembled, because these two materials are incompatible in terms of recycling, because they are two different polymers with two different transformation temperature and so on, and blah, 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 blah. There are lots of knowledge there beside it, you have to know, but this helps you to make, in this case, you make a comparison, which is edit comparison, and when you go to the radar, you can, okay, here you select not the normal, but the deep. Here I didn't do anything, so there is nothing shown right now, because I didn't put any value there inside. This is to say that like it's good to use life cycle assessment, definitely, if possible, especially at the beginning. especially at the beginning, within existing product, okay? And to understand where are the biggest problems, where you have to focus, because many times that is a big mistake. People think it's the waste. The worst, in some cases, it is. In many other, it's not. It's the material, it's big, the impact there. But just because it doesn't last nothing. So you reduce material, you make something that lasts even less, and you improve the environmental impact of the. Okay? So it's not just the life cycle. Life cycle is very important, but then you have to make a bridge towards, you know, the way in which we as performance of the given product. If you don't have the possibility to make a life cycle assessment because the company say to you, no, low budget, it's a difficult time. You make at least a qualitative assessment, or you don't have at the beginning because you start the money to buy a Sima Pro, make anyhow a qualitative assessment and do and use something. But said this, the key tool of that is the idea generation table. Okay? Even though you have not been doing the things over there, it's good to be that you have been doing that, but at least try to generate the idea in all the different, in relation to the all possible strategies. Before, you know, getting in love with one concept, you have one idea. No, is not to lose time, lose a bit of time to explore all options and all ideas. Either they are very diverse. Then you come, you cluster them, and you will see which are the best. If you have priority, it's better because then you will understand which idea are the most important. But if that is not possible, at least use the idea generation table. Okay? They are full of content, full of knowledge, and that's it. I think that that's for today.
Thank you very much.
It was just an improvisation. We
Thank you
really
very
didn't
much.
plan it.
Well, I think this shows the importance of having this gap between engineering and design, no? That maybe really improve the environmental issue with products. I don't know that. No sé si la doctora quiere agregar.
No.
We will be using, maybe I was discussing with Dr. Silvia that maybe we will be using this tool that was shown by Carlo in our last exercise for the engineering students. When we are proposing and redesigning our exercise in life cycle assessment in CIMA Pro, after we get the results, we can use the tool so you can propose, as we said, a new product. Okay? So you can make friends with our design students, and maybe they may be useful for you at the end of the period. And design students, engineer friends are always welcome because sometimes we don't know even how to make conversation.